Welcome back to the Accomplished Brain podcast, where we talk about brain health, chronic neurological disorders, and other current health topics. So today we're going to talk about neurotransmitters. So when we think about neurotransmitters, we basically want to think of our body's chemical messengers. They're molecules used by the nervous system in order to transmit messages between neurons. So, when I kind of think of at a basic level of, how are neurotransmitters helping us, hurting us, so on and so forth, we want to think of kind of what parts of the brain can they affect. And I think a lot of times it becomes oversimplified of, this type of neurotransmitter is excitatory and this type of neurotransmitter is inhibitory. And I think Andrew can go a lot into that. There are actually like much deeper levels of that. But, just to give an example, like somebody who has classic ADD where their frontal lobes don't function too well, we want to give them dopamine. Dopamine is going to have a huge effect on the frontal lobe in order to boost that functionality and help us concentrate better, make more decisions, so on and so forth. Another example would be if somebody has PTSD, right? So those are issues in the anterior cingulate, the basal ganglia. A neurotransmitter that's going to kind of help calm those areas down are going to be things like Gaba, which, yes, is an inhibitory type of transmitter. Things like Gaba, things like serotonin. So I do think that in a lot of ways, the basic language that we see on neurotransmitters is way oversimplified of them being either inhibitory or excitatory. But as we kind of go through this podcast, you'll see the power that they have to change our mood, change our energy levels, and what they're really doing kind of at a chemical level. I do want to get a little technical here, and it's important to know that there are actually two different categories of neurotransmitters. There are small molecule neurotransmitters, which are made within the axon terminal. And there are precursors necessary to make these molecules as they're taken up by selective transporters on the membrane of the terminal. Others are just byproducts of cellular processes that take place within the neuron itself and become readily available. Now, the enzymes are necessary to promote an interaction among the precursors. They start in the cell body and then are transported to the terminal. So an example would be something like acetylcholine. Acetylcholine comes from choline and acetate. But the synthesis of acetylcholine requires the enzyme choline acetyltransferase. I'm pretty sure I pronounced that right, but that's an enzyme that takes place within the nerve terminal in order to help synthesize choline and acetate to create acetylcholine. The neuropeptides are the other type of neurotransmitters, and those generally range from anywhere from 3 to 36 amino acids in length, so they tend to be much larger than the small molecule neurotransmitters. Also, neuropeptides must be made in the cell body because their synthesis requires a peptide bond formation. So similar to any protein made by the cell, it starts in the cell nucleus, during which a specific peptide coding sequence of DNA is used as a template to construct a corresponding strand of mRNA. This mRNA travels to a ribosome where the process translation begins, and during this translation, a sequence of nucleotides that are made up of RNA act as a code, string together a corresponding sequence of amino acids that will eventually become the neuropeptide that we see at the terminal. So those are the two different types of neurotransmitters, or excuse me, I should say categories. There are actually over 100 neurotransmitters that we know of, but kind of what you see a lot of people talking about nowadays, we focus on the big four. Some people call it the big six, the big five, so on and so forth. So there are tons of neurotransmitters out there, but when we think of, what's going to affect our mood or energy levels, most of the time we're breaking that down into 4 different categories. So I think Andrew's a lot better at kind of breaking down, each neurotransmitter, and he's going to talk about how they come about and how they can actually affect us.
Great. Thanks a lot, Jeff. And again, tremendous value. I love, how we start our podcast because I get to learn again, and that's what we talked about and emphasized that we just here to share both of us information. We both learn from each other, and we learn from everybody else. So we're just sharing our knowledge, and we just want to give value to as many people as we can. So this is a great topic in neurotransmitters because the communication between the nervous system can happen uh, on on an electrical level and on a chemical level, right? So obviously we've talked today a little bit about the chemical level. I do want to mention that on the electrical level can also enhance the chemical level. We'll talk about that. We talked about that in a little bit of the vagal nerve, and we'll kind of bring back to that where you can, where certain instances you can increase the production of certain neurotransmitters with exercise stimulation. But let's just talk about some. Obviously, Jeff said there's many neurotransmitters, but let's just talk about some and what do we see them for. So two of the I'm going to start off with talking about dopamine and serotonin. So really important. Okay. So first off, I want to talk about I want to talk about the serotonin. So serotonin is uh, to make serotonin. It's very important that we talk about this because there's a whole chemical like equation to make the serotonin. One, serotonin needs tryptophan. Okay, so and I'm going to talk about so when we talk about tryptophan, you could get these in foods. So I'm going to talk about some of the foods that help because the tryptophan is the first compound that needs to be made for serotonin. Tryptophan is shrimp, mushrooms, snapper, halibut, chicken breast, scallop, spinach, turkey, grass-fed lamb, grass-fed beef, grass-fed liver, wild salmon. All those can make tryptophan. So you could get tryptophan in food. And then what happens is 5-HTP turns into serotonin. But in order for that equation, so tryptophan turns to 5-HTP, 5-HTP turns to serotonin. In order to get serotonin, you need to have good stable blood sugar. So here's where um, the functional neuroscience comes in, right? Like, so, it's not just about the food. It's about, hey, we need to make sure that our blood sugar is in good place. The second thing is we need to have iron, right? So it's important one to have to look at your ferritin levels, your stored iron, also to make sure that I have good gut function, right? So I can absorb, I have the ability to make iron. The second thing is so blood sugar, iron. The third thing is B vitamins. Okay, so magnesium. So what did we talk about last time? We talked a little bit about like some of the magnesium and potassium, right? We get those in green leafy vegetables. So we talked about this at night, right? Like we talked about making serotonin, right? Because one of the things, so where are the some key areas that Jeff and I look at serotonin is one is mood modulation, right? So we all know that serotonin is the happy or the modulation of mood, right? Is the happy neurotransmitter. So the other thing that you're going to see serotonin in is to modulate pain, right? So we talked last week about, or we talked, well, when we talk about the vagal nerve stimulation, we talked about one of the ways so this is where the stimulation comes in and activating that vagal nerve and the vagal nerve, the auricular branch using the TENS unit. We talked about we can increase the production of serotonin. Well, that's going to help modulate pain, right? So that's your descending pain pathways to not, and we're going to, again, every time Jeff and I come, come aboard, we're like, okay, we have to do another podcast. We think of all our podcasts on the podcast,
Right.
meaning
Right.
that we talk about like information and we realize, you know what, it'd be a great thing to talk about pain and chronic pain and some ideas to inhibit chronic pain. So vagal nerve stimulation to lower your inflammatory response, especially in your gut and immune system. But secondly, the increased production of serotonin. And then serotonin helps to modulate pain. The third thing we talked about serotonin is it's a precursor to make melatonin to help you fall asleep. So remember we talked about that equation that so part of the equation is a couple things. So we're going to talk about sleep. And we're going to talk about how important these neurotransmitters are. Well, one is when the cortisol has to be low in the morning, right? So then what happens is you have to have increased serotonin because it's a precursor to make to melatonin, and then you want melatonin less serotonin high, precursor to make melatonin high to dull that pineal gland and allow us to fall asleep, right? And we're going to talk about sleep, and the other neurotransmitter is GABA, and we're going to talk about sleep, the neurotransmitters, and all the neurotrans and the sleep and all the neurotransmitters, right? So so the thing about serotonin that's very interesting is you can ask certain questions to see if they have serotonin deficiencies, right? So some of the questions you can ask is do they have a loss of hobbies? Do they feel overwhelmed with ideas to manage? Do they feel feelings of inner rage? Do they have feelings of inner paranoia? They have feelings, obviously, of depression. They have feelings like they're not enjoying life. Do they have feelings of lack artistic appreciation, right? So those are usually some of the questions that could feel that you could have a lack of serotonin. And serotonin, you want to make sure you're getting tryptophan in those foods, right? Shrimp, mushroom, snapper, halibut, chicken breast, scallops, spinach, turkey, grass-fed lamb, grass-fed beef, grass-fed liver, wild salmon, right? And then tryptophan turns into 5-HTP, which turns into serotonin. And in order for that equation to work, we need good blood sugar, we need good iron, good B vitamins, good magnesium. We said green leafy vegetables, B vitamins, magnesium, potassium, right? Also green leafy vegetables. Those are good for anyone who has blood sugar problems also, right? And then obviously spinach is, if you're eating green leafy spinach, that'll be also a help. So, that will be a help as well. So, so those are the things as far as the dopamine, right? So dopamine, and this is another interesting neurotransmitter, is dopamine starts off with making tyrosine, right? Tyrosine turns into L-DOPA, and L-DOPA turns into dopamine, right? So what happens, people with Parkinson's usually is that, and we're going to show you that on our course, that dopaminergic activating system. So up in the mesencephalon, up in the upper brainstem, is your ventral tegmental, your pars reticulata, the substantia nigra. All those are areas up in your upper brainstem are housing the dopamine. So let me bring that up for a second here. I'm going to bring up our course. So I always like to do our course here. So we're going to screen share this. And we're going to we're going to move Jeff over here. We always like our course. We always pay homage to our man Mike for doing all these amazing diagrams, right? Yeah. Oh, here we go. Right here. So you see this picture here where it says the nigra, the ventral tegmental, the pars compacta, the pars reticulata also. But this area in orange is your mesencephalon. It's your upper brainstem. This is called your dopaminergic activating system, because when you fire dopamine, you are going to blast the brain and the sublayer of the brain. Okay, you are going to fire up to your frontal lobe. You're going to fire up to your limbic system. You're going to fire up to the basal ganglia. So we call this we call this the ventral, the mesencephalon. So we call this the mesocortical for the cortex, the mesolimbic for the limbic system, and we call the basal ganglia the mesostriatum, right? So the mesostrial pathway. So all three of these pathways, the sublayer and the brain, get blasted with dopamine. So that's what happens is when people who have Parkinson's have a lack of dopaminergic. So one of the things we use with the Parkinson's clients, and I want to bring this up, okay, this is really cool. So I'm going to bring this up, put this over here, okay. So I'm going to bring this up. Okay, so we're gonna bring our activities up here. Okay. Okay, so let me just bring this up. I'm going to bring this up in our software. Okay, so in our software, we have a program that we can virtual reality vestibular program. We can move you in 18 different directions. We have all these different sceneries. So one of the clients that I have, look at this. This is golf, right? And this is beach. And the reason why we use these sceneries, especially with the Parkinson's, especially with people who have lack of frontal lobe activation, like Jeff talked about, the kids with ADHD, the kids who have attention difficulty, right? We have for kids in amusement park. When you fire a scenery that somebody likes, it's like eating chocolate. Oh, well, if they like chocolate, so it's like eating chocolate. If they like chocolate, what they call that is a reward. And a reward, anytime you give somebody a reward, you are going to stimulate whatever is left in their dopamine system. So the thing is, we can increase the dopamine by using foods, right? So some of the things, what foods can make to help make tyrosine, wild game, right? We have grass-fed beef, grass-fed pork, wild fish, turkey, organic turkey, um, you know, cheese, oats, chocolate. All of those can help make um, can help make tyrosine. It turns into L-dopa, which turns into dopamine. And again, in order to have that equation work, okay, the tyrosine, L-dopa, and dopamine, again, you need good blood sugar, iron, B vitamins, magnesium. Sees all these things. And I want to share a couple of things that can affect the serotonin. So what happens is, what could affect the serotonin could be in females having too much testosterone, uh, and in females and males. In females, estrogen, too much estrogen, and in males, too much testosterone. So all those things can affect the serotonin, and dopamine can be affected. Their receptor sites can be affected, again, in females by estrogen and in males by testosterone. Okay. So again, just to recap, both serotonin and dopamine, they have an equation. In serotonin, it's tryptophan, turns into 5-HTP, which turns into serotonin. Need good blood sugar, right? In order for that equation. So in tryptophan, you can get that in food: shrimp, mushroom, snapper, halibut, chicken breast, scallops, spinach, turkey, grass-fed lamb, grass-fed beef, grass-fed liver, wild salmon. So you could get those tryptophan in food. Then in order to turn 5-HTP from tryptophan to 5-HTP, and then from 5-HTP to serotonin, you need good blood sugar, iron, B vitamins, magnesium. We said that serotonin, some of the things you could see people with lack of serotonin is if they lose hobbies or interests, they feel overwhelmed with ideas, they feel in a rage, they feel in a paranoia, depression, not enjoying life, they have a lack of artistic expression. Okay. Now we said that serotonin, mood, right? Modulation of pain. We also said that serotonin can help with sleep because it's a precursor to make melatonin, and melatonin can dull the pineal gland to allow you to fall asleep. We said dopamine is made in, a lot of it is made in the upper brainstem. Okay, the sub in the mesencephalon, your upper brainstem, right? You're in your substantia nigra, pars compacta, ventral tegmental. That area of the upper brainstem then fires up to blast the brain, the cortex, right? The front, especially the frontal, the parietal lobe, and the limbic system, as well as the sublayer of the brain called the basal ganglia, right? We said the basal ganglia, right, has an influence on motor. It doesn't have any direct connection, but it influences motor movement. It influences cognition, eye movement, and your emotional limbic system. Okay. So we said that people with Parkinson's have this decreased dopamine activating system, right? We said that with serotonin, let's go back, that you could use the TENS unit, right? There's some activation. We said with dopamine, we could give, like in our vestibular virtual reality, we could give people a scenery that they like playing golf or a beach or with kids, an amusement park. That scenery that acts as a reward, the brain likes it. Anything that the brain is going to like is going to drive and drive the dopamine system. We said with dopamine, tyrosine turns into L-dopa, which turns it into dopamine. We said that in order for that equation, so you could get tyrosine, right, through certain foods, wild game, right, grass-fed wild game, wild grass-fed beef, grass-fed pork, wild salmon, turkey, organic eggs, grass-fed cheese, wild oats, and cacao, chocolate, right? We said that tyrosine turns into L-dopa, which turns into dopamine, but same thing like serotonin. In order for that equation to happen, we need good blood sugar, iron, B vitamins, and magnesium. I didn't cover this, but I'm going to talk about this now. Is that some of the dopamine that when people have a lack of dopamine, they feel worthless, they feel hopelessness, they feel self-destructive thoughts, inability to handle stress, anger, aggression under stress, do not feel rested after long hours of sleep. They don't feel rested. They desire to isolate from others. Those are all dopaminergic type of lack of dopamine. Okay. So we said that both serotonin and dopamine can be affected, the levels in females by estrogen, too much estrogen, and males testosterone. Okay, so it's important not only with these neurotransmitters, but to look at blood sugar, look at iron levels, look at gut function, look at B vitamins, look at magnesium, look at hormones. That's why when you look comprehensively, everything comes back to functional, right? Whether it's functional medicine, functional neuroscience, functional, I would say energy. Everything is coming back on how everything relates to each other. That is homeostasis and healing. Okay. So some of the things, as we said, is giving sceneries that people like, the TENS unit, very powerful stimulation. So the other thing that we want to talk about is another neurotransmitter is very important, is acetylcholine, precursor for memory. Really important, the acetylcholine for muscular function, really important acetylcholine for the digestive system, really important for the vagal nerve, right? So not only are you and a precursor to make acetylcholine is phosphatidylcholine, which you can get in supplement, you can get in eggs, you can get in liver. These are all really good things. Now, really important about acetylcholine is acetylcholine, again, when you're drying that vagal system and the digestive system, the cholinergic pathways are really important. So again, making sure you're getting, if you're not alert, if you don't have an allergy, organic eggs, making sure you're eating the yolk, right? You're just not egg whites, getting in liver, grass-fed liver is like your superfood. It's make sure that it's grass. I mean, I tend to really like liver, but it's just a good food. I mean, I think they should come up with some kind of, a friend of mine once said, come up with like a liver kind of supplement, like some kind of liver beef jerky or something. It would be a great idea, because liver is just, and they have a universal taste. Because I like the taste. Some people like it, some don't. But I think it's just a universal. It's such a super food. Um, you're also getting good iron in liver, right? In your meats and everything. So grass-fed meat. So that's why, I'm a big proponent of making sure you're eating grass-fed meat. But obviously, some people do have an issue when it comes to the animal and how they look at the animal, and I totally respect that. So I want to let people know that if I ever worked with someone, I would kind of work around those if they had some kind of kind of energetic or emotional feeling towards eating like animal meat. I would very much be respectful to that, and I try to figure out how to work around that. As we talked about, energy is the most important thing. So, but yeah, so acetylcholine, and also acetylcholine is very important for the autonomic nervous system, because the autonomic nervous system is like two parts. It has a pre and a post. That's how it works. And we should do another podcast on autonomics. Like, again,
Right.
every time we got a new one on pain, new one on. We're going to be doing more, but every time we come up. But if you look at the autonomic nervous system, which I think is homeostasis, and I have really been studying this and have some really great ideas. But what happens is you have a neuron that fires to a pre-ganglionic group of neurons, then they fire to a post that fires to some kind of organ. So post to the organ. Group of neurons, preganglionic, on both sides, whether it's sympathetic, which drives our nervous system, or parasympathetic. The pre is acetylcholine on both sides. So in order to drive the autonomic nervous system on both sides, you need acetylcholine. Second is the parasympathetic, postganglionic neurotransmitter is acetylcholine. So most people, I'm going to say not most, I'm going to say a lot of people, including myself, are in this sympathetic drive. I mean, that's the environment. We work, we have minds, we're in sympathetic drive. So to calm us down, we need that acetylcholine. I mean, acetylcholine is also known as a driver as well, but I look at it as a modulation. Sometimes acetylcholine is used to stimulate and drive, but there are other times, depending on where you're using it, if you're using it to activate the parasympathetic and drive that system, acetylcholine is important for the memory as a driver. But it's also important for the parasympathetic system. Okay. Also, acetylcholine is important. So in sleep, when you're getting your REM sleep, I'm going to talk about that, because we went over sleep, and what happens is, so let's go back because we want to go into, I think we want to go into two more neurotransmitters, Neuroepinephrine and Gaba. And then I think that's pretty much, we'll wrap that up today. But your GABA is important, because that's your main neurotransmitter that's going to calm you down, right? So when we talked about in sleep, so let's go back to the sleep, and we said in sleep that a couple things happen. Cortisol has to be low, right? And then serotonin has to be high. It's a precursor to make melatonin. Melatonin dulls the pineal gland, allows us to fall asleep. Also, to allow us to fall asleep, very important, is GABA. GABA in the hypothalamus, which is sublayer of the brain, right? So you have your thalamus, hypothalamus sits behind that. GABA in the ventrolateral preoptical area, GABA fires, and then GABA inhibits a hormone called orexin, right? And orexin usually arouses us. So orexin has to be inhibited, and we said histamine has to be inhibited in the lateral and posterior hypothalamus. That the lateral and posterior hypothalamus are both your sympathetic drivers, right? So GABA in the ventral, which is mostly in the anterior part, the ventrolateral preoptical area, has to inhibit that. So you have to have GABA. One thing I found that could help with GABA is using vestibular. The reason being is when you fire a vestibular canal, the opposite canal has to be inhibited. In order for that opposite canal has to be inhibited, you have to drive GABA. So I sometimes tend to have clients do their TENS unit or their vestibular virtual reality exercises at night before they go to bed to kind of ramp up the TENS unit, stimulate their lower inflammation TENS unit to increase serotonin, allow them to fall asleep, and then the TENS, and then the virtual reality vestibular. Because if I'm moving my head, if I'm activating, say, this ear canal, the right ear canal, the left ear canal has to be inhibited, right? It's just how the system works. If one is activated, the other is inhibited. In order to inhibit, you could stimulate the GABA. The other thing that can happen is we could give them an anti-saccade. So we could let's just show this on our. We're here. We might as well just show this on our. While we're here, we might as well show this on our software. So let's do this. So I'm just going to show you what else. So we could give them an anti-saccade, okay, which is an eye movement program, right? So when I go into this, I have my activities here. We can go to Optimizer, which is we have two eye programs. This is our eye program in 2D, right? So real simple. Just say I wanted to give a green. I'm working on colors. I want to do a whole thing with Jeff on colors. I'm telling you, Jeff, we should just stay on on point. I'm just going to do this one set. Reaction time 3 seconds. We'll do more to, say, the 70% to the right. Right. And we're just going to do a dot size. The direction is left to right. Okay. We just do 4 reps. And then basically we'll just press play. And the concept is your eyes have to look opposite of the target. So obviously you saw the target come left, you want to look right. Target comes right, you want to look left. What you're doing in this is the eye wants to move towards the target. So when you move left, when you move opposite, so an example is if the target comes right and you're moving left, what happens is, to inhibit the eye to want to move towards the target and hold its position, the right dorsolateral prefrontal cortex has to fire. That prefrontal cortex fires down to the inhibitory basal ganglia, right? So the inhibitory basal ganglia will start to calm the eye system, the motor system down, the cognitive system. You'll start to dull the brain down. So we could give people anti-saccades before they go to bed, right? And also that pathway, that inhibitory basal ganglionic pathway, uses GABA. So you see what I'm saying? So there's a lot of ways that we could stimulate the GABA system. So GABA is that inhibitory neurotransmitter that helps you fall asleep, helps you relax, calm yourself down. Some of the things that you'll see with GABA, with an issue with GABA, is if you feel anxious, do you feel dread doing things? Do you have knots in your stomach? Do you feel overwhelmed for no reason? Do you feel guilt about your everyday decisions? Does your mind feel restless? Difficult to turn your mind off when you want to relax? Disorganized attention? How often do you worry about things? These are all, if you have feelings of inattention and inner excitability, those are all lack of GABA. Acetylcholine, some of the questions: do you have a memory problem? Are you having a hard time remembering names and phone numbers? Do you notice the ability is your focus declining? And you have a hard time learning things? How often do you have a time remembering appointments? Is your temperament getting worse? Are you losing attention? Those are all questions about your memory and the acetylcholine. Okay, so I just want to focus on one last is your neuroepinephrine, and that's your main neurotransmitter to help drive your nervous system. And basically, that helps your heart, so your heart to contract. It helps all your that helps all your sympathetic, so it helps to drive your system. We need it. A lot of times, what will happen is we get too much of it. So, and here's here's the thing. Um, there's a precursor to make your norepinephrine is dopamine. So that's an interesting thing, right? So
Mm.
people who lack dopamine are going to also lack the ability to make norepinephrine. So they're going to have, so that's why you see the Parkinson's people with slowness of movements and stuff like that. So really important. And we talked about the sleep. When you sleep and you get into that 1 to 4 range of sleep, all your neurotransmitters are inhibited. So just remember that. So GABA is firing in the beginning to dull everything. And then once you fall asleep and get into that 1 to 4 zone, like all your neurotransmitters. And then what happens is all your neurotransmitters inhibited. When you get into that REM sleep, you're the only neurotransmitter that's active is acetylcholine. So just and that's that precursor to, that's when you're getting in that REM sleep, the REM, when you're dreaming. And the reason is a closing. It's like you do have some brain waves that are going on during the REM, which is good, right? So you get fully rested, and that's why Jeff went over that the cycle isn't like,
Right.
it's not an ABC. It's constantly going back and forth. It's kind of like 3-dimensional. You're going 1 to 4. You're going into the REM, back to 1 to 4, back to REM, and then eventually you wake up.
Right. And that note on acetylcholine makes a lot of sense, because in REM sleep is a huge part of when we're actually storing our memories so that they're firm in our brain. So
Exactly.
makes a lot of sense.
Exactly. So I just wanted to share. So I just wanted to share some of the neurotransmitters, not all. I wanted to share that there are ways that you could for food and supplements, and then there are ways that you could use stimulation to help these neurotransmitters. They're important. So again, and just recognize that, like, when we use a reward, we're using certain areas of the brain, and also when we use a reward with stimulation, we could get very specific with what side of the brain and stuff. When we're using the antipsychotics, what side of the brain. When you're using like a food or supplement, it's more general, right? It's both more global, right, approach. But that's what happens. I mean, I think when, like, you're kind of mixing back and forth. I always talk about therapy is 3-dimensional, right? And I think that's why Jeff and I are on to some good stuff. How we're working is the world works in these 3-dimensional, from a conscious state to the neuro integrated with functional neuroscience, functional medicine,
Mhm.
right? And then functional exercise. It's
Right.
all in this 3D state. That's why, like, again, when you go in, and I think you're in a pathology, I think it's important that they do a really good job with, they're focused on trying to either save a life or stabilize or do some kind of life-saving thing. And I think that's why their mechanism works. But then when to get the body is back to full itself, it needs that 3-dimensional. So one's not better than the other. They both, so just a different way of looking at it, but they both have huge value.
Right. And Andrew, if you don't mind, I actually mentioned this in a podcast earlier, but when you talk about, how the exercise actually has a lot to do with it, we talk about exercise stimulating serotonin. They don't actually, exercise itself doesn't actually create serotonin, but what it does is, when you think of molecules passing through the blood-brain barrier, tryptophan, right, a small little molecule, is in competition with big, strong amino acids crossing the blood-brain barrier. But what happens is, when we exercise, those amino acids are now being in demand for our muscular system, and therefore allowing less competition for serotonin to pass the blood-brain barrier. So again, we brought up exercise, and I think it's important to know is, how important cardiovascular and strength training is for something like serotonin when we need to calm our brain down or make us feel better. Serotonin can be greatly increased by something like exercise.
Right. Absolutely. 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 Yeah. And I think, so I just think, I think this was another great podcast. And Jeff, could you note on this podcast that I think there's a couple things that we want to do is one is another with the autonomic nervous system and pain. I think that's the
Yeah,
two
sure.
separate podcasts, but this is really good. This is really good. So I love this. This is, and I wanted to share also with you, we're not coming from a perspective of end all be all. We're trying to give value in, Jeff and I probably have over 30 years of experience, which, together of working in this field. So, just like any other field, there's many ways to do things. But we're just trying to give value on what we have experienced, what we've read, what we've worked with clients, and we just, sharing what we're doing to try to help as many people as we can.
Absolutely. Absolutely. Well, thank you so much for joining us today, and we're looking forward to the next podcast.
Great. Thank you.